All right, kiddo. Excuse me. We're going to do another example of distance equals rate times time problem. This one is in the PDF from section 7.8. It's example 5. It's driving to Florida. So it says, Susan drove 1,500 miles to Daytona Beach for spring break. On the way back, she averaged 10 miles an hour less. And the drive back took her 5 hours longer. She was excited to get there, so apparently she was speeding on the way there, and then she slowed down on the way back. And it says, find her speed on the way to Daytona Beach. All right, we're going to do a distance equals rate times time chart. And we're going to do going to Daytona Beach and then coming back from. Okay. So her distance to Daytona Beach is 1,500 miles. Her distance back from Daytona Beach is 1,500 miles. Okay. Her rate going, we don't know. We're going to call it X. But we know coming back, she went 10 miles an hour less. So she slowed down on the way back. She was probably tired from all that sun and sand and beach stuff. In case you're wondering, I have my Diet Coke. Okay. So her time, remember that distance equals rate times time. So if we divide both sides by rate, distance divided by rate equals time. So her time going is 1,500 divided by X. Her time coming back is 1,500 divided by X minus 10. Now, what do we know about the relationship between these two? Coming back, excuse me, took 5 hours longer. So 1,500 over X minus 10 has to equal the going plus 5. Does that make sense? Coming back took 5 hours longer than the going. So the going plus 5 equals the coming back. Okay? And the book, when they did it, they said the longer minus the shorter equals 5. Well, if you move mine over, I get that same equation. The longer minus the shorter would equal 5. I'm just doing mine this way. It'll give you two different ways to look at it. If you look at the example in the book, in the PDF that I sent you, they set it up ever so slightly different. They moved that over here. All right. Let's put our understood 1 down there. All right. I want to get rid of my fraction. So I'm going to multiply everything by the least common denominator, which has to have a 1, which is irrelevant, an X, and an X minus 10. That X minus 10 will cancel that X minus 10, and I'll have 1,500 times X equals, that X will cancel that X, and I'll have 1,500 times X minus 10. The 1 won't cancel anything, so I'll have that 5 times the X minus 10. Now I'm going to do my math and simplify things. All right, distribute. I'm going to distribute 5x. 5 times x is 5x. 5x times x is 5x squared. 5x times negative 10 is negative 50x. So far, so good. It's a quadratic equation because of the squared. So everything has to equal to 0. So I'm going to rearrange everything. I'm going to move that over, and lo and behold, it will cancel that. So now that 1,500 and that 1,500 are gone. Let me rearrange. 5x squared minus 50x minus 15,000 equals 0. I've got to factor that, and I can see that they all have a GCF of 5, which is going to make this a tricks problem and not a general excuse me, general trinomial. All right. Two numbers that multiply to give me 3,000, but subtract to give me 10. Well, doing it in my head, I'm thinking of 30. 30 is 5 and 6, so 3,000 is 50 and 60. To get a negative 10, it's going to have to be a negative 60 and a positive 50. I now have two baby equations. X equals 60 or x equals negative 50. Now look at what x was. It was her speed on the way there. Her speed on the way there can't be negative 50. That's a nonsense answer. So the speed on the way there, I don't guess she was speeding, she was doing the speed limit, is 60 miles an hour. So going 60 miles an hour, and back she went 50 miles an hour. Now let's see if that checks. Okay, I'm going to turn to another page. So 1,500 miles at 60 miles an hour. Get out my calculator. That's 25 hours on the way down. Then on the way back, 1,500 divided by 50, we can do that in our head. It took her 30 hours, and it said her way back was 5 hours longer, and sure enough, that works. So my correct answer to this problem is her rate on the way down was 60 miles per hour. Right? I am going to stop this video now, and I will tell you that out of your homework, you can now do problems make sure I'm telling you the right one. That was example 5. You can now do problems 33 and problem 34.